This is the Blackjack app routine for dealers' total percentages. It is subprogram 8, tab 0. It first sums the 10 frequencies for the number of cards that it has in the deck. It says then if that total, which is in S, is less than 20, it's not going to do this operation. It's going to branch to AP. If it continues on because there's 20 or more cards, it does a reset to all probability tables. Then it copies the tables from seed SG0 to seed SG plus 1. Then it fills the 23 values at found count with 0. That's going to include the found count for when the dealer got 17 to 21, plus the found count for 22, which is going to include any time he went over 21. Then it's going to say for L is 1, and way down here we have till L is 10, can get to 10,000 one at a time. It says it's going to perform these operations in here 10,000 times. Alright, when it starts in the loop, the first thing it does is it sets A to 0, which is to indicate he doesn't have an ace. But then it says if the dealer card is not equal to an ace, go to AC. But if it is an ace, set the value of A to 1. A is going to be used to say whether the dealer has an ace or he doesn't. Then it sets the T, which is going to be the total of the value of his cards, to the dealer's up card. That's the value he'll start with. Then it's going to do a puck operation, which means it's going to draw a card from the frequency table of the cards left in the deck. Then the next line does an add 1 to the value it found, because that value is going to be a 0 through a 9. But the card values are 1 through 10. So that we add 1 to C to get the value of the card. Next, it says if C is not equal to a 1, go to AE. Otherwise, add 1 to A. Remember, A indicates how many aces the dealer has, or basically that he has at least one ace. Then it adds the value of the card to the total, T. Next it says, if that is greater than 16, well, the dealer stops then. He goes to AF down here, which means he's done picking cards. Next, if that's not true, it branches if less than, his A value is less than 1, indicating he has no ace. So in which case all he can do is go to AD up here and pick another card. Well, the other choice is that yes, he did have an ace. So then he comes down here and he says, but branch if it cannot have 17 with the ace. In other words, branch if less than 7 to AD. He still hasn't made it to 17, even though he has an ace, so he still has to go get another card. But the other thing is true, branch if it would go over 21 with the ace. In other words, he can't do that either, so he has to go to AD and pick another card. Otherwise, he's done, because with the ace, he made it to 17. So we're going to use the ace, so we're going to add 10 to the total. Then we're going to say, is the total greater than 21? If it is, we're going to go to AG. Well, that's right down here. If it's not, we're going to add 1 to our found count plus t. That is, t's either a 17, 18, 19, 20, or 21. We're going to add 1 to that count. However, if it went over, then we're going to add 1 to the found count plus 22. Alright? Then we're going to come down here to a p set. The p set sets the frequency table back to what it was originally. We want to set the probabilities back to the way they were, put all the cards back in the deck, and go around for the next one of the 10,000 trials. Now I advance the screen so I can get below the next L10,000 to continue on. It sets the value of X to 200, the value of Y to 290, sets the color to 3, which is a dark blue, the font to bold, 25 pixels, and says the text probability for each total. Then it changes X to 50, Y to 325, and it's going to go around the loop of the found totals for I-17, and down here you see next I-22, one at a time. So for each possible total, it's going to go around this loop. It's going to set the value of I, which is going to be from 17 to 22, and put it into line. Then it's going to say, well, but if it's equal to 22, it's going to fall down here and put the word over into the line instead of saying 22. And it's going to fill the 2 characters after line plus 7 with 124, which are 2 vertical bars, which is what text looks at when it's going to put something on the screen. The first vertical bar says it's the end of the field, and the second one says don't advance the value of X. Alright, well here it's going to put it on the screen. Then it's going to add to Y 30, and then it's going to put the number of times it found it into line. But 7 positions, 2 decimal positions. So there's 10,000 times, so it's essentially going to divide the number because it's forcing 2 decimal places, and it's going to be understood as a percentage. So there's 4 decimal places. So the next thing, it fills the 2 again at line plus 7 with the vertical bars, and it displays this text on the screen. Then it subtracts 30 from Y, putting it back to where it had been, and it adds X 140 to move things to the right, and then it goes around to do the next number. So it's going to go around here for each table value, 17 to 21, and then the last time it's going to say over. Now I advance the screen again. Here's where it ended the loop from 17 to 22. Now it's going to go on, and it's going to set the value of X to 0, Y to 220, the color to 400, which is a dark red, the font to bold, 25 pixels, and then it says the number of S is going to be put into line with 4 positions. Then it shows that text on the screen, and then right following that text it says there must be at least 20 cards in the deck. Alright, this is the routine that calculates the percentages for the 10,000 playing of the blackjack game.